Welcome back, everybody. My name is Legit Lee, and I'm back again with another video, well, basically another stream of CNC designing. Right now, as you can see, this is going to be a new part to CNC designing. I designed this machine here. It's not anything fabulous. It's like 20 by 20 or 20 by 40 or 80 by 80 aluminum excursions that you can buy pretty cheaply. But it's not that solid like I would want it to be. So right now we're going to kind of get some information off of here and design something completely from scratch that I'm probably going to wind up going to machine shop to have them cut out for me as soon as I get the measurements and see exactly what I want. So this is a good start for anybody that's trying to do something of the same similar aspect. But there's going to be, ifs and buts here and there, but for the most part it should be relatively straightforward, and we're doing everything in real measurements. So we're using like millimeters. That's usually what most people use for CNC work. Like most CNCs use millimeters to cut for the most part. I mean, I live in America, but most of the stuff I use is millimeters. But anyway, so what I'm going to do is I'm going to get rid of most of this stuff off of here. We're going to use some of it because I have designed this. If you haven't seen the last stream, it would have been part 3 for the CNC machine designing in Blender. I went ahead and designed this spindle motor that I bought from Banggood, and the mount that it came with, this bracket. So all of this is like real world information that for the stuff that I bought. I designed it as close enough to the specs as possible. And then these are linear rails that I got off of Thingiverse, and then they're glide blocks I got off Thingiverse, and then these are 8mm threaded bearings, which we're not going to be using these lead screws. I mean, not bearings, but lead screws. We're not going to be using them though. I'm going to try to use they're called 16, I believe, 1605 ball bearings, screw heads. So they have like ball bearings inside of these screw nuts that a lot of people have been using, that actually helps with smooth motion for the most part, and they're relatively cheap. You can get a lot of them from China and Banggood and stuff like that. But so right now we're gonna be designing pretty much everything from scratch. I want to make some like aluminum plates and things of that nature. There was this YouTuber online that I liked his machine for the most part, but it was a little too small for what I'm trying to do. His machine is called Stupid Strong CNC. It's Mike and Lauren. They're a popular YouTuber channel, and he has this design that I liked. I liked the fact that he had the roller bearings underneath the bed plate, so like when it moved back and forth, you wouldn't have to worry about the dust or anything getting onto your bearings really. But I'm not gonna have any bearings. I'm gonna have like literally these rails here, these linear rails, because I already have some. So I'll be buying, if I need to buy more I will, but I'd rather stick with rails than like lead screw stuff. But I'm gonna grab this picture real quick. Well, I'm gonna snip this picture real quick of his design. And
Part series, we're going to go from
there we go. So grab this. I'm sorry guys, just have to grab this picture really fast. There we go. So I'm gonna save this picture so we can use it as like a reference image of what he made. I'm kind of be building the same thing a little bit, but my stuff's gonna be there's gonna be a lot more different, and it's gonna be bigger for one. So if we save as just say CNC I don't know, design, and I'll save it in pictures, so that's good. So we're not going to start completely from scratch with this, or because we're going to need some of this information here, so I'm going to save some of this. But for right now, I'm going to hide everything else. So we'll just do hide. So you can kind of just start from scratch here. And I don't want my machine being too big, but I definitely need it bigger than what he had. So, yeah, I'm gonna hide that too. And I don't know if I need these bearing blocks. I mean, I don't know what the size is for the ones that I'm gonna be getting, or most likely buying. We hide those and this. And that will be my bed. I have a 16, at the moment, a 16 millimeter, I think it's like 1/4 of an inch thick. It's not 16 millimeter. I mean, it's 16 inches. So basically like 400 millimeters thick aluminum plate that I haven't used for anything and I bought it a long time ago. I bought 2 of them. It was for my 3D printer, and I'm turning that 3D printer or using the parts off of the 3D printer to make the CNC machine most likely. But for this, let me just go ahead and remove the spindle picture. We don't need that. And I don't need my NEMA 23 bracket because I already made that. Don't need this. And Stain Smart, that was just a picture of the other thing I was using. Now we can go ahead and grab the pictures that we need. So I have to go to my pictures, I think. And where is it? CNC, right? CNC Design JPEG. There we go. And I don't need this, so I'll hide that. Hide. The reason why I'm not deleting it is because if I do need it, at least it's there. We're just hiding it behind the scenes. And we can put it on, oh wait, not that. And we can put them on like a different layer of Blender. So like if I decide to put them here or something, I can do that. But I'm not going to do all that right now. We'll just hide all this other stuff. So we know for sure that we're going to be needing lead screws, the linear rails, the blocks that the rails ride on, pillow block bearings for the lead screws to roll in, and then the spindle shaft, and my motor mount plates that I already have coming in. And this is a 400 millimeter squared print bed surface basically. And yeah, so I think we can save all the rest of the stuff. So first we're gonna do is, and we already got the image in, but you can't see it. It needs to be bigger. So we're gonna scale this up if I can. Here we go. No, there we go. So just drag and pull. So this is his design. I just screenshotted this off of the YouTube video, and it's nice. Don't get me wrong. I mean, he did a great job. I mean, I didn't see him cut aluminum with it, which that's what I'm trying to do. I don't know if he had a video. I haven't double checked this channel yet to find out, but I want to be able to cut aluminum with my stuff. That's the main reason why I'm most likely gonna have to build it from scratch here. But yeah, so his design looks pretty good. I like this gantry part and everything, but like I said, I'm gonna have linear rails on here. So, and I'm probably not gonna have a lot of movement travel because I mean, literally, if my spindle moves up and down, I only need about, you know, what, 2 millimeter, like at least 4 inches worth of travel space. I think would be good. It's just because like I want to be able to cut thick wood maybe in the future, so like a 4-inch travel height from the bed to the spindle, I feel like would be good, because then, you know, if I have 2x4s or anything, or 4x4s or something that I want to cut out or mill or do some kind of like 3D design out of wood or something, I can do that. So I'm trying to get the information set up so like future me can be able to use this machine for like other projects that may pop into my head. So first we're gonna go ahead and start off with getting this gantry plate stuff going. So right now I want to make sure that we have at least, I want to do really like 2 feet worth of travel, so I may have to change this bed plate because this bed plate's too thin for me to put screws in. So if you like look at this guy's design right here, if I let me bring up the opacity really quick so you guys can see it better. Right here he has these screws mounts into the bed, so the X gantry moves completely, the bed stays still. So we have screws here, and that's some pretty thick aluminum plate. I think his is 3/4 of an inch. So I need something that thick too, because mine isn't thick enough for me to be putting screws in the front plate like that. I mean, it kind of could I will have to use like some thin screws, which I don't want to do. So I'm gonna have to like resize this to be basically like 2 feet is what I want to use. It's because like I know soon I'm gonna probably wind up doing like a lot more anime based designs. So I'm gonna be doing like, I want to do like computer cases and all kind of crazy stuff. So I need computer cases, like the size of it is like 56 centimeters, which equals out to like 22 inches. So I need something that's at least 2 feet to be able to cut out some like, legit PC cases. So I'm gonna have to have like a 2 feet, like 3/4 of an inch thick aluminum plate. So for that, let me just see what exactly. I don't know exactly the measurements between millimeters and inches like that to know for sure. But let's see, if we do 24 inches and millimeters, that would be equal to 609.6 millimeters. So basically, let's just say 610 to round it off. So if we make this build plate here, let's go to top view. 609. Right now it's at let's go to object mode here. We have to select that edge, and I'll do this right here, segment show. That's showing all the other segments, everything else which I don't need. Good. So let's go here. I'm going to get rid of all the other ones I don't need, so that way they're not in the way. Okay, good. What is this? What is... Oh, 400 is what I just did. Okay. Sorry if it's taking long, guys. I'm trying to get this cleared up. And if you guys need me to do so, if you message me and say, hey Lee, can I get the design of the spindle motor, that part right there, then I'll probably just throw it on Thingiverse. I haven't decided if I'm already gonna do that or not. So I do have a Thingiverse account, I just haven't posted a lot of stuff to it. It's just I design a lot, so it's hard to like get all my designs out there. But it doesn't mean that I don't have all the stuff. Like I just designed this bracket, which is a real world bracket that I just ordered off of eBay to mount my NEMA 23 stepper motors. But it works for both. The bracket I bought actually has the ability to have 17s and 23s. Anyway, so we know this is 400. We'll go over here. Oh, wrong button. There we go. We'll go over here. We want to make sure that this side is segmented as well, which I'll do green for the y-axis, axes, whatever. And then we're going to scale it to the measurements that we want, or we can just, you know, change it here. If I go object mode and then go to right here, dimensions. See, this is 40 by 400 by 400, but it's 40 by centimeters by 40 centimeters. But we're gonna do, it's 400. So if we do 610 by 610, that would be 2 feet. But that's, you know, that's 2 feet squared, and I probably am going to need it a little longer than that. So the y-axis will probably have to be a little longer. So we can do, if it's 400, 600, 2 feet. Let's just do 700, make it easy. So then if I need to, like, you know, mount it or something, we'll do 700 by 610. That'll help out. And now we can, we need to make it a little thicker. So I don't know what 3/4 of an inch is. Let me see. 3.75 is 95 point. Oh no, that's 3. I'm sorry. 75. 3/4 of an inch. It's 19 millimeters, basically 19.5, 19.05. So if we do front view and then we change this to, let's just do 19 to make it normal. 19 millimeters thick. You see how thick the plate he's using is? That's a lot more thicker than anything else, but we have it, so it works out, whatever. And I don't know if I can change. I know I have that. I think it's fine. Oh, that's right. The lens. No, that's. Is that right? Maybe I can zoom out a little bit. Oh, I'll just leave it at 35. Anyway, so we have the bed now, and what we're gonna do is we need to design this part here is the X gantry's plate. So that's actually super simple. Like, I think this design will be a whole lot quicker than the last one. So if we go to Shift A, add a cube. I'm not sure how thick I want it. I mean, I know how thick I want it, but I don't know how long it should be. Trying to think here. Want to make sure I have good travel. Oh, since I can get this, we'll hide the picture for right now. So if we just close the eye on the image, we'll do, what is, I think this is 52 millimeters thick. And then we have the motor is like 50 as well. So maybe like 100 wide or like 150. We could start off with that and see where we go. So we'll do 150 on the Y. And then let's see, how tall do we want it? 500 maybe? 500 millimeters maybe tall enough. We'll start off with that. The length, so we'll do 5. Oh, my bad. 500. And then the X, we're needed at 2. What? Hold on. Why isn't it longer? Oh, I didn't change it. Okay, so yeah, we need 150. Enter. There we go. And then this guy needs to be 19 millimeters thick. See? So that's basically the same thickness as this, I think. At least it should be. I put 19. I don't know why this one looks thicker. It's weird. Oh, that's scaled. Okay. That was my mistake, guys. I apologize. I typed it in scale instead of the other stuff. Right? I think so. Yeah, that was on scale. I should have did 19 millimeters on here. There we go. So that's better. So now they match. Okay. Now if we want to just drag this guy over here. Granted, it's going to be a little off the table because it needs to be able to travel, right? So we don't want it too close. Just drag this over just a tad. We're like right there, halfway. See, it's close enough, but not touching. So we bring it up. Right there, looks good. And bring it over so we can see. So yeah, that actually looks like it did pretty well. It may be a little too tall. I don't know yet. We'll see when we start putting it all together. So that plate, and he had a plate in the front and a plate in the back, so we need those. So we can just duplicate this one. And so I'll just do that really quick. So duplicate. We'll rotate 90 degrees. Drop it down. It's about here. Move it forward. It's about there. And then well, we probably need to center it up a little better than that. Good, right there. And we'll go to our orthographic on the right side. Rotate 90 degrees. Push this forward. And bring it up too. And I'm holding down Control to drag and move it because it's locked into place. So this one's not long enough. You can see I need to extend that out a little bit. And it needs to be pulled forward a little. I don't know if that worked. Not the way I wanted it to. Is that right? I don't know. Maybe it is lined up right. Not really. It's off like a hair. Or maybe it isn't. I don't know. I can't see this one. Why is that? That's weird. Yeah, it's off by like a little bit. Not a lot. Just a tad. That one will have to touch because we're gonna obviously make sure that the stuff's touching and it works and all that good stuff. So we're gonna need to stretch this out to be what was this one, 70 on the 61, so yeah, 610. So we need to scale this out to 610. So if we do that on the X, do this, I don't know, it may not be on the right one. Hold on. What we can do to make sure, oh man, yeah, that's right, because this I flip rotated and it's not in the right axes and in its normal space. So the best thing to do is just scale on the X and control, and I will just drag it out to the proportions we want. And if we want to get better scaling and dragging, just zoom in, scale X, control, about there, looks okay. And so now we have that, and I'm gonna pull this. Why does it look like it's touching? I don't understand what's. Oh, it's not touching nothing. It's this here. Let me hide that. That's in a way. Hide. Okay. So, good news is it's tall enough, but I don't know if I want it to be that high up. Let me just look at the screw and the information here, because we're gonna have the motor, you know, obviously mounted to the back and all that good stuff, because it's gonna be going through here. It's not gonna, I probably won't even use the plate that I got for this. I'll probably just be mounting it straight to the back plate of this machine, like how that picture was for the most part, I think. So that's not bad. I'm just trying to think if I need this one to be that tall up, because I mean, anywhere I could save some money, the better, you know. So I'm probably just gonna make this a little smaller. So if we go in here, scale on the Z, see how that looks. Drag this up. And then we could bring it down. So we're gonna have to bring both of these down. And drag it down like this. Alright, to touch the build plate surface. Okay, and golden right there. Okay. So now if we look, now this is kind of smacking right here, but when we duplicate, which we're going to do right now, this to move it back, we're going to pull this guy forward because it's kind of too far back. I want it kind of lined up in the center a little bit here, because now this doesn't have to move. We basically, the bed itself was going to be moving on my last design, so this one isn't going to move. It's going to be the gantry that moves. So now we just duplicate this guy, shift D on the Y because we're on the Y-axis viewing, and we'll have to zoom in a little bit, and then we'll just bring you back one. Good. Okay. So now we have, I'm going to make these different colors so we know that there's two separate plates, basically. So I don't know why it's doing that, where it like cuts off or something. We're going to do this one, let's say yellow or something, just some random color, because we don't want it to be the color that it's showing. I want to know what I'm looking at when I'm looking at it, so I'll do like a yellow or something that makes it a little easier to see too. Make it bright. Come on. There we go. And same thing with this guy back here. Or we can just delete this one and just duplicate the one we have. That'll just make it easier. instead of trying to get the colors to match. Shifty on the Y, move it over there. Zoom in, move it over 1. Good, done. Try to speed this up here, guys. I know talking forever and all that good stuff. So now we have our information here. We need to move this guy down a little bit because we're gonna have another plate that sits underneath that boxes it all up. So we'll move right here. So the plate that this one is, we need to have another one that goes across. So this one is going to be duplicated and then brought over here. Then we have to scale it out. So we're going to duplicate again, D on the Y, bring it all the way over here. Then we're going to rotate 90 degrees. Then we are going to scale on the Y. Then we can move it over 1, or zoom in and move over 1. Zoom in, and then pull. Good. Alright, right there. So, this will need to go up a little bit, or this table part will need to go down. And that's probably what's going to happen is we're going to have to move it down, but we're going to scale it a little bit more. S, Y. Oh, not that one. Undo this guy. S, Y. And we can move it over just a tad. S, Y, bring it in a little bit more. That's fine. We're not trying to get perfectly matched up because I know what the measurement's going to be once we're done. But see right here, I don't know. Let me just double check his design, but I don't think it would show us his information about. Yeah, it's not showing underneath how he mounted his lead screw block. But I know I've seen the video. I have to watch it again to like design it right. But nonetheless, I'll go ahead and hide this really quick again. So far already like halfway there. We just have to duplicate this one and put it on the other side. But first I want to bring it down a little bit and change the height because it's a little too tall. Like I said, I'm trying to save where I need to save at because I'm going to be buying pieces of aluminum like this shape and drilling the holes and everything out myself. But what I'm trying to figure out right now is this is like 200 millimeters square travel. So I don't think I need that much space to travel. I'm not drilling anything that tall. So, you know, if I have just like 150, I feel like I'll be alright with that. This one is, what is this height? What's your height? This one's 500, yeah, so that's too tall. We'll do 4. Let's see what 4. Oh no, not 40. 400. 400. Bring it down. Still too tall. Maybe 300. Bring it down. That looks kind of alright. I don't mind it being 300. Maybe do like 350. Give it extra boost there. That's not bad. Bring it up. There. So that's not bad. 350 looks like it'll work for what we need. Then we'll just go ahead and duplicate it now. Shift D on the X, move it over, and voila, good. And then we will need one that does the back right here. So we're not really, I mean, I may do a top one just to make sure it's always squared around. I don't know yet because when it comes to sliding back and forth, usually you don't want to have a top rail. I don't even think anybody's design really has that going on. I mean, I'm pretty sure they do, but not this guy's design. And so if I go to his image here, open that back up, So yeah, he has like a small piece that goes over there. That's why it's cut in an angle, which is fine. We can do that. So yeah, I'm gonna hide this picture again. We don't need it. We'll duplicate this one, just make it a little smaller. So Shift D on the Z, bring it up, and then we'll have to scale it back on the Y. So if I do Z, and then we'll do SY, just bring it back down. What is that size? What's the size on the Y? SY. So this one is showing 75, almost 75 millimeters. It's almost 75 millimeters. So I mean, I can make these like exactly what they need to be. So I'm gonna just do that really quick so I know exactly where I'm working with, because I'm not trying to do like Blender whatever. I'm trying to do like real live measurements. So we'll do Shift D. Nope, not that. We'll do Shift A, cube. This should be what? Ooh, if this is 610, we'll probably need 600 and give me extra 10 on each side, maybe? No, what's 10 on each side? So I just want to make sure the travel is good and that it won't smack against each other, but I don't want it too far away from it. So that's 10. Yeah, I don't mind an extra 10. Yeah, extra 10 should be good. So yeah, we can do 10 on each side, which will be 600, and if it's 610 here for this, right? 610 on the X. So this, the new cube that I just brought in, if I can find it now. Where are you, cube? Oh god, I lost it. Alright. Is that the cube? I don't know. It's hard to see. Yeah, that's it. That's 2 millimeters. So if we're doing 610, we're adding 10 to each side, so we need 630. So 630 by, what is this? I don't even know. I forgot the length of this guy here. Honestly, I don't remember if it was, the X is that Y, 75 millimeters. 75 millimeters by 19 millimeters thick. So if we do Z, and then I can just move this over. Alright, so bam. So now we know exactly where we're at. We can delete the other one if we want to. We have to just bring this one down. Oh man, don't tell me I messed up again. I put in the wrong, I put in the scale. I need 19 on the Z. There we go. I don't know, sometimes I do it so quick I don't even pay attention that I'm in scale or the other thing, in dimensions. So we have that, I think. No, that's not it. We have to go down a little more. That's this one. That's fine right there. Okay, so we have that. We can delete the other one that we don't need. X, delete. So now that we know what that one is, we'll duplicate it. Z, bring it up. It's about right there. We'll delete this one. X, done. And this guy is, I think this is actually alright. That scale. We just have to position it where we want it at. I think it's like off. looking through it, so one of these aren't going to be right. We'll just delete this one. So I know I'm working on the right one here. I want it to line up with this guy up here. I think I did. Yeah, that looks pretty lined up to me. Alright. Good. So now we can just duplicate that around. We have to bring it down a little bit though. If you can see, it's a little too high. That doesn't match up. So if we zoom in enough. Down, down, down. How many is that? We probably need about 2 more. Okay. Alright. 1, 2, perfect. There. Numbers don't lie. And this guy, what are you doing? I need you to go down to 2, buddy. Or 1. You're not lined up properly. I don't understand why that is. We want you to line up, sir. There we go. Alright, so now that we have that, granted it's a little far out, so we have to move this guy out a little bit more. Says if you see here, it's smacking, so we need to bring this guy out. Too much. Estimate. There we go. That looks okay. Okay, now we just duplicate this. Oh, actually, no. Well, yeah, we'll duplicate it. D, Shift D, X, all the way over here. Good. So now we have that duplicated, and we probably need to line this one up a little bit because it looks a little bit off. To touch that line. Okay. And then now we have the top and the bottom, but now we need to, I'm going to change the colors so we can see what's top and what's bottom. Okay, so now you can see it's like boxed up, but we don't want that exactly. We want to have this like little indent curve thing going on. So I'm not sure what millimeters I should work with that. First, let's go ahead and move our motor and our information around. I'll just hide this one for now, then we'll figure it out. So we know that we're going to be moving a block over, so we need to get another mesh in cube basically, and we need to do, I don't know, what's this, is 56, no, 89, this is 89 for the mounting bracket from end to end. So if that's 89 on the X, we can do, I don't know, 90. I mean, even 100 would be alright. I feel like 100 will do okay. And then on the Y, we're at, this is 200 travel for that, but the Y would need to be 3/4 of an inch, which is 19 basically, or 1910, whatever. And then the Z, it's gonna be like 200, so we need to drag that up, our base plate, and then we're gonna move it forward, kind of match this other information up, and change the base plate to a different color too. Let's just make this one a completely different color. I'll make it red. Yeah, we could do red. I'll make it a nice shiny red here. Okay. So if our base plate is red, which looks pretty good for that, we'll draw that up. So yeah, maybe it was more than 200 millimeters. Which that is a pretty good amount of travel. I don't really need that much, but I mean, I'm not gonna complain about it if I get a piece like that. But I know that the spindle, you know, obviously the spindle's kind of big and tall, so I want to make sure whatever travel this thing has, it can do it. So basically what's going to happen is this is going to be attached to this, and so this will move back and forth, because this will be attached, and then there's going to be a lead screw that holds the back plate to it, so the ball head screw will just be moving back and forth there. And then so I need to get some like shims or something that'll mount this plate to this if I'm doing the ball behind here. So I don't know yet, but at least the groove or the plate or whatever. Okay, so we'll just move this guy back. Shoot, I don't think it does it when I'm doing this. Okay, let's just get right there. Good. So this will basically be right there, and it doesn't look too bad, and it's really close. Like, okay, the bottom is a little too tall, which is fine, because if we're, yeah, because it will smack something. I think I'll have to probably bring these closer into each other or whatever. Besides, it's not tall, it's like it's overshooting the gantry part here anyway. So we'll bring this down to about like right there, and this guy can go up to about right there. What to say? That's not bad. The same thing goes for you two. Gonna bring you up so I can see. Good. And then these guys back here. Bring you down. Good. So then we have that moving back and forth. Now this can go up a little bit because I want to make sure that the block that it's sitting on, the plate or whatever, is gonna be like centered up right. There we go. That looks pretty good. Then we can move these guys back against here, because then I can just drill in a plate that attaches this one here, so that way we'll have movement of my, the mount for my motor. And then the ball screw will probably have to be back here behind all this. So let's go ahead and import the ball screw that I found on Thingiverse. I don't know if I downloaded it yet. No, spindle mount, no, pillow block for 10M shaft, nope. Okay, so I didn't bring in the screw yet. And this screw right here is the same as that screw that I'm going to be buying, except for it's smaller. So I'll have to just basically import it in and extrude it or scale it up or whatever. It's fine. So I'll download this really quick, save to my desktop, done, and then we'll go back to Blender, get our information up. So we need to import STL and that one, that's the screw head part. Bring it up. We don't need to bring it up that way. We bring it up this way. Good. And then we can just move it over one or like a half or something so we can line it up with everything. Good, right there. And then we'll have to rotate it, obviously. So first we'll do it on the X first, since we're working on the X. So we'll do rotate 90 degrees. Good. And I'm gonna have to bring this guy back up to about there. I want to make sure that's kind of centered. No, I don't believe it is. It's not centered yet. Okay, so just right there looks centered. Okay. And now if we just bring this back over here, and say like it's touching, you know, the motor information, and then we can just duplicate that shift, or we can go into object mode, and then we'll do shift, duplicate on the X, move it over. But we don't need that back part right here. So I'll hit Z, B, oh wait, A, B, bring this, no, shoot, I forgot I'm in, move this out of the way. So I'm used to working with like single objects or whatever. No. B, grab this, move it in, close into this gap here, and then we will grab all this with B, bring this guy in to touch. So it kind of works, sort of. You won't really notice it. This is just for demonstration purposes, so. And there goes my camera again. I don't know if it's because it's getting a little warm or what's happening with it right now. Let me just shut it off. Unplug it. And we can shut that out. There we go. Sorry about that, guys. I guess my camera is just getting a little hot, which is understandable. I mean, I don't think it like went down. I think it was still like viewing me, but maybe, I don't know. I have no idea, to be honest, what's going on with it. But it's okay. Anyway, that's what I was saying is, we'll deselect that. No, wait, undo. We want to select that one. We want to duplicate it again. So duplicate this one on the X. Good. Then we'll just do Control R to redo that same duplication. Oh no. There we go. Over and over again until we get towards the end. And we probably need to do it one more time. Shoot. Okay, it's not allowing me to do it again. So duplicate on the X. We just want it to stick out a little bit, I guess. I don't know. It depends on how we're setting up our pillow block stuff. I'll have it just stick out a little. It's fine. Alright. Now that we're done with that, we can go out of here. Looks okay. Anyways, so that will be our lead screw. So if we do that, and we have to just pull it back a little bit here because we have to go behind the gantry system, because it's gonna have to actually go all the way through everything. We'll grab this and this and this, and we'll pull it back, because you see that hole right here is what we're trying to get set up for, because that is where our stuff is. So we need to pull you this way. It's not gonna be perfect, I guess. So I zoom in some more, maybe. I don't know. I guess that'll work. Right there, right there, around there somewhere. It's not bad. I mean, we're not gonna do it perfect anyway. But yeah, so that allows us to get the gantry set up here. So that's not bad. Now we need to. That's the only bad thing. I'm trying to think, like, there needs to be a plate right here, I guess. I don't know. This is a little strange because we need something to mount to this, which is going to be the the bearing block nut thing, and then. But where is this gonna sit at? You know. That's a little complicated. I gotta think, because the linear rails need to be riding on something. Unless I cut like little parts that allow it to ride on it, like long piece of aluminum that'll go from here to here. I don't know yet. Let's go ahead and just get the back piece in first. So we'll do this. Duplicate. Z. Bring it up. Then we'll rotate 90 degrees. Then we will pull it back. Pull it back. Good. Somewhere around there. And we need to bring it up just a little more. That's fine right there for now. So let's see what's going on. So that's what I'm saying, like this is gonna be pushing that, but this needs to be mounted on a wall, you know? So I don't know how I'm supposed to do that. Let me just double check something here. This guy and his stupid CNC machine stuff. Yeah, you go from that to that. I understand. So he's doing the bottom gantry, shaving off whatever he needs to shave off. So he did where it's the top and then the back. See, I just don't know how fat my stuff's gonna be to allow movement like that. But he's mounting his pillow block against the back of the wall, kind of. So like, there's a bearing block. He has that mounted up against the wall. Then on the top he has a piece that has the sliding rail. I mean, I can do that where the top and the bottom has sliding rails, but I'd rather not do that if I can manage it. Because I really don't want to do that at all. I mean, I know that'll be a lot stronger and will never move, but I don't know, like, see, I don't know if my side mounting for this would be all that great, because it isn't. I would have to figure this out here. Shoot, man, this is complicated. I can see why he went with something so big. His protrudes out kind of far. I guess what I could do is have a piece that mounts underneath here. We'll have to bring this up, and then with it mounts in there and here, then I can get it to mount right on that piece. That would work. So it'll be more pieces that need to be on there, but it would work. Yeah, let's try that out. So let's just duplicate this guy. Duplicate, Shift D on the Y, bring it over, Z, now we're gonna rotate 90, bring it up, I have to bring it back. We can move it in the center and then I can scale it, or I can just, I don't know if the dimensions are gonna be right. It's 300 on the X, that makes sense. Y is at 75. Yeah, I don't know about that one. We'll do 40. What is 40 millimeters? How thick is that really? Honestly, I'd rather just have a flat piece that goes on that wall. Why is it so complicated right now? I don't understand. Let me see if I could look up some other pictures of another one here. Images. See, because everybody got these ones like riding on rails and stuff, but they're like using balls and trying to figure out how to do it with like a regular rail. Sorry if it's taking too long, guys. It's one of those things that, you know, you run into an issue, you gotta double check your information really quick. How did he do this one? See, this guy made a complete, he used like, oh, that was pretty smart. I don't know if I want to do that though, because that's a lot of aluminum. He made like an aluminum complete housing all the way around, which probably would make sense for me to try to do. And then he had like the lead screw connected to here in the front, and then he had the motor connected to a nut and a belt, and then it pushed and pulled the lead screw back and forth. I don't want to do all that extra work for this. I mean, it's not bad. I really just don't want to have to box it all up. I mean, granted, it probably would be better to do it. No, it wouldn't. Now I'm thinking about it, it probably wouldn't. I mean, it would for some things, but not everything. But, let's see, try another one here. What's this? Nope. No. Jeez. I don't even know if my motor is going to be able to pull all this thick aluminum stuff, man. If it does, it won't be able to do it fast. I know that for sure. This is needlessly complicated for no reason right now. I really feel like there should be like a simple design about this without having to use like roller bearings or boxing up the whole entire thing. So I may have to get those long roller pieces that he used because I don't think I'm gonna have any other choice, to be honest. I mean, they're not expensive, so it's not a big deal. But I really wasn't trying to do that. Unless I add like metal plates, like a bracket that goes from, you know, here to here. I don't want to do that either because that'll be pushing it further out. Yeah, I'm looking through some pictures, guys. I'm sorry if it's taking long. Honestly, I don't really see anything I can really use. I don't know. We'll just try to design something of a workaround, I guess. I mean, these aluminum, that's 19 millimeters thick, so I feel like if I was to add it to all this, it should do just fine. So we're at, what is this, 40 millimeters? This is gonna be a lot of screws to put in here, but it'll have to do, I guess. Like, I can't really find anything that'll really work the way I want it to for this. So if we bring this up, and then you are like really weird right now. I don't know what's going on with you. Yeah, now you can do it. I need you to move up. What is that? 5, 5, and 5. Okay. I think that got it, hopefully. Am I right? Nope. Okay, that's weird. Oh, that's all it did, huh? I need to move into like right here to 5. There it goes. I was too zoomed in. Perfect. Now let's do this. I'm just trying to make sure everything lines up squared with each other so I don't get thrown off. Okay, so this is 40, so it probably needs to be a little smaller than that if I want it to stick out well. Well, yeah, well, I don't know. Maybe I should just push this out a little bit. I mean, I don't mind doing that. Let's see, this 40 part is actually smacking this part. I want this part to be up against here, so we can actually make that a little smaller. So instead of it being 40, what is this, 19, oh no, this is 80. 40? 40 is way too small. So what is that? 50 then? 60. Okay, that's not gonna work. 50. $55, so 60 is too much. 58. See, like right like that, this will mount, this piece will mount up against here, this will mount against here, and then here too. So then we just have to duplicate this one, Shift D on the Z, bring it down. So right there. It'll make it a lot more solid, I can guarantee that. And since these are separate different parts, I'll just change the color to like, what in the world? Oh. Undo. I wanted, let's do yellow, yeah. And then for this particular one, I'm gonna change the color for. Man, why does it want to change everything? Shoot. Oh, it's because he's using material 3. Do that light blue or something, and so you will have to change so now we know where the back plate is and where everything's mounted up at. So that's not bad. We can move the motor up a little higher with the screw. I mean, how high was the picture? We can check. Check this one out. Shoot, my stuff is in the way. I can't really see. Oh wait, see, there we go. See, I was kind of high up to the top. Yeah, we can move these all up here. So that's not bad. Oh, I didn't move this guy back though. He needs to move back. So we're not really using these exactly, but I just want to get a good reference of where everything's gonna be sitting at. And now, so we would have to put screws in here, so at least 2 to 3 on each side of here, and then all through the back of here and down here as well, and same thing, 2 to 3 there and 2 to 3 here. for the tops and the bottoms and everything to make sure everything is really straight. And then right here we're gonna cut this down at an angle, so we're not gonna have it that long. We're gonna make it actually line up right next to this, so it'll be a lot easier when it goes back and forth. And we cut off some costs, I guess, for the aluminum. I don't know, but it'll give a nice little design to it that I would like. So how we're gonna do that, we're gonna go here, move in object mode, A, Z, B, grab this guy, and we're just gonna pull it back to line up with this one right here. Perfect. Now we get back, do the same thing with this one, tab object mode, A, B, grab this, pull it back right to here. Good. So now we can see the design looks pretty nice. So it's coming together pretty nicely. This table is 2 feet by what, 700 millimeters, so a little over 2 feet. So that way we can cut all kind of different stuff on it. I mean, it's pretty basic, but it'll have some really good rigidity, I would say. I guess that's what it's called. I don't remember. We're gonna grab these guys, and I guess this guy, and this guy, and this guy, and this guy, and this guy. And we're gonna pull all this back and up. I need to bring it up. Honestly, I don't know how thick the plate is for where my stuff's gonna be sitting on top of here, but it should be good. Okay. Zoom in a little more. I need more. Does that work? Yeah, it's perfect. Okay, it's lined up good. So, as you can see, we have the ball screw. Say it's this one, we need to duplicate this and put it on here. So what we'll do is, here we go. Shift, duplicate, then we'll rotate negative 90 degrees. Drag it over to the center of this guy, pull it up, go to 3, pull it forward. That's too far. Okay. I think that'll work. Nope, still too far. What about there? Good. Alright. So say like that was connected and everything, and that's the ball head and all that good stuff. If I do, there should be another piece in here. Oh, I just touched it. We'll delete that one. We don't need it. So yeah, that's looking pretty good. And so now that we have that, we need to make a piece that allows it to go up and down from here. So we would have to get something that'll work for this part. I'm not sure how he did it, because he had aluminum angle brackets for that one. And let me see this other guy's stuff. So you had a plate on top of another plate that mounted the other plate. So he had like 2 plates. I may have to just make me a complete motor mount without this. So we'll just hide that. I don't think I'm gonna need it, because I need something that'll mount up against here. So we'll have to get something that attaches to this. So what we'll do is just duplicate this guy. Duplicate, rotate 90 degrees, bring it up, bring it forward. And then we can, well, we need to scale it, so we'll get it to like right here. Then we can scale it down. Scale on the Y. And we'll bring it forward, and it's good. So that's not bad. I mean, granted, it's not perfect, but it's not bad. I don't know. It's one of those things where you just don't know until you try it, right? I just hate to spend money on this stuff if it isn't going to work the way I want it to. Duplicate, Z, down. And then we bring it down, down, okay. I don't know if that's gonna work, man. I'm trying to like piece some ideas together here. It's just because the ball screw, well, I mean, if I'm doing a plate now, I guess I could move this back some more, since I'm not going off of the design. So if I grab these and pull this back, I don't even know what the, oh yeah, I can grab it, hold on. Somebody made the block. Yeah, he got the block. We'll just grab that. That'll make things a little more easier. Alright. Extract to my desktop again. There we go. Done with that. So we go over here. Go to File. Import again. STL. This one. So there goes the block. We'll drag it up. Move it over. So if we rotate 90 degrees forward, move it over. Then we'll rotate 90 degrees negative and bring it over. I need to make sure it's mounted on the block. See, that's the thing, because it's going to be mounted on the block. So this is the block here, this isn't it. So right there. Now we bring it up. Bring it up. I can just drag it all the way up here. Honestly, I don't know how far up we need to drag it to, because it needs to be centered for the most part. guess that's okay right there. Anyway, so now we can move these guys back to see exactly where we're going to be at with this roller stuff. So these are lies. I mean, I shouldn't even be using these because they're not the right height. But I'll still keep them just to see, but I don't really need them. Grab, and then we grab this one. We're gonna pull this guy back. I think that was too much of a pull. We can check. It looks kind of insane, guys. I can't see. I don't understand what's going on. See, yeah, I was two back. Two forward. That looks pretty good right there, I think. Yeah. Alright. So, that means we can make this a little smaller. We don't need it that far out. Then we can add, you know, the blocks that we need or whatever. But see, that's what I'm saying. I don't understand this. That's right, because this is going to be the lead screw part. This will be mounted to the block. So this will have to be rotated the opposite direction because this is the part that moves. I'm still trying to figure out how I'm supposed to mount something to this guy here. Because this needs to move up and down, right? And then the screw is going to be pushing that plate. I don't know why this stuff is going to be so complicated. I mean, literally, I could just do side mount these parts and then have like a... But I don't know how far off on the sides it's going to be doing. Because I want to make sure I have travel 2 feet. And plus, if I'm doing it off on the sides, there's a chance that it can get dirty too. I need to think. Let's see. I guess side mounting it won't be so bad. I can't really think of anything else at the top of my head, but if I figure out something later on, I can change it. But for right now, we'll just do side mounting this stuff. Why not? Not too happy about it, but it is what it is. Alright, so... Oh, wait. Move it. Rotate 90 degrees. Good. See what I mean? I'm gonna do like a side mount. Alright. Grab this and this. And then we'll do another side mount for this part, so we'll just have to move it. And then top view, rotate negative 90 degrees, because we're opposite directions. And then push right there. It's probably a little too... It's not centered right. That right there, and then we need to move it down one. Oh, that's good. Same thing with this side. So it needs to move you over one and down one. Good. Bring it up too far eye. That's not bad, I guess. That's fine right there. See, now that will help out, and then we don't have to have these two that long. And then all we have to do is get another piece like this to mount to this part. So we'll go ahead and scale these down some more. Or I can just tab, B, C, grab this, and then we'll just pull it back. Enough to make sure we drive our motors into this thing at least. It's like right here. Let me go in. I'll just pull this right here. That should be good enough. I think that matches up, right? Nope, it's the other one. Good. So now we have our ball head screw stuff that needs to be pulled up. Which will be a block anyway. It's gonna be a block. Doesn't matter. That's fine right there. And then this top one needs to be pulled. Oh, that's actually good right there. Okay. So yeah, so then we'll have those two. This one needs to be rotated around 180 degrees. So R 180. Then we need to bring it back to the center. Alright, so basically at that point we'll have a plate that's attached to this plate that allows it to move up and down. Only if that motor, that NEMA 17 motor wasn't so big, yo. Sitting in like the wrong area, man. It needs to sit above. Because then if I can make this part, I mean I think I could still make it kind of flatter. Let me just bring the motor down so I can see. There we go. So it's gonna be, I don't know, we have to see because it's gonna be touching all this. I can move it forward a little bit. I'm just trying to keep it really flat and flush because I don't want to have any weird stuff going on, but it's pretty sturdy as it is. I mean, it will be pretty sturdy. See, like right there. Allow me to drill the holes all the way through. then I have to move all this over. I don't know how I feel about having all that gap area, but if it needs to be done, it needs to be done. Shoot, I don't know. Alright, so if we move this to line up, I think that pretty much did it. Yeah, that looks alright. So then if we grab this, shift, duplicate on the Y, bring it forward. See right there, it'll touch and then push this mechanism up and down. And then we will just have to get plates that attach to here and here. So this will probably have to be a little wider, so that way the plates can match up. But I'll have to do... I don't know how I feel about that. Yeah, I guess. I mean, there is other ways to do this, but the only problem I'm having is with these bearing sliders, man. I honestly don't know. I mean, I know mine are actually, I think they're like 20s or something. I can't remember what I bought. I gotta double check. I don't know if they're 20s or 15s or something, but they're some thick pieces of metal, so. But for right now, we'll just measure out this. I'll probably have to come back to this design in a little while after I figure out some stuff, but let's just go ahead and grab the other plates that need to be wrapped around this one. So first we need to grab this, and this, and this, and this, and then we're gonna bring them all down to like the center of all this here. And then we'll grab this guy and this guy, and we're gonna bring this down to the center too. See if I do that, it's not, well yeah, the center, because then once it goes down, they all move together. So if I grab those two, say it does go down, goes down pretty good. And so, but yeah, I only have like a little bit of play right here. I'd rather it go down some more. Could say like, you know, the bed and everything. So I may have to pull the whole assembly down. Grab all these. And all these. I'll do Z, see if it moved everything. Yeah, I think it did.
Oh man. Still debating about the back part and how tall this thing is. I may need to bring it down some more. I don't know yet, because the bed isn't going to move. It needs to go all the way down to touch the bed frame. Well, not the bed frame exactly, but, you know, get really freaking close. I mean, I know this height actually isn't too bad, because we're going to have obviously a wasteboard that needs to go there. And plus I can always bring the spindle down a little bit more. Let me just grab these really quick. And drag those down. To the bed frame. Good. And then so say we got a bed on here. Well, this is supposed to be underneath anyway. I haven't even started working on that part yet. And then this part needs to be fixed for this lead screw stuff. Let's go tab, and I'll just delete all that by doing B. We'll select all these vertices. Okay, so this goes back and forth. The bottom will have to do the back and forth movement. I'm just trying to figure out how much top and bottom I would need. So I want it to go high and low. Like I said, this is 200 millimeters though, so I honestly don't know about how high I want this thing to go or how low it needs to go, because this stuff right here needs to be underneath the bed anyway. Honestly, I hope it can even hold that heavy mass of stuff. I may wind up having to do those ball leads, but I won't know until I get everything pieced together. So far for sure we know that I need to get, I need to fix these. I did not see that. The sides here, they need to get fixed. Tab, we're gonna do Control R to do a loop cut. GG. Alright, now hit this, hit B, grab it. That's too far out. Okay, let's zoom in a little bit then. Nope. Guess it's not bad. Yeah, it's not bad. You know what's crazy is I feel like my CR10 can print this all out. Like I'm thinking like, you know, if I wanted to really see it in real life before I even cut all this stuff out and do everything, I could just print it out on my CR10. Gotta love 3D printers, man. They're great. They're just so great. Alright, so we're going to do the same thing for the other side. Loop cut, tab, GG. Bring it down to that level. Grab this, pull it forward, zoom in, pull it forward. Good. It's not bad. It's coming out pretty good, I think. We can go ahead and start moving this guy backwards. Okay. So, you know what? I didn't even design the plate to do that. I'm bringing this down like the plate's gonna bring it down. I'm dumb. I need to put the plate. I need to grab this plate. Yeah, I don't need this plate this long. What's the height of this? 20, that's 200 millimeters. Change that down to 60? Okay, no, not that. 80. $80mm plate. Or maybe 100. So if we go, let's pull this up and down. This will stop about here and stop, click, click. And then this needs to go down. I'll hit that right there. But this will wind up getting smacked. Still a little bit of travel, I guess, but still want to get smacked at some point. Oh man, I'm trying to think what is going on here. So that does not give me much rigidity. These will have to go back a little more. The lead screw have to be longer. Let's see, that's what I'm saying. This part, they don't give me much travel distance. So this stuff's just not good when it comes to this traveling. I found somebody kind of designed something. It looks okay. Really, I may wind up just buying a freaking mechanism or something. I don't know. We'll see what happens. But I'll go ahead and duplicate this. Shift, duplicate. Then we're gonna rotate 90. Z, pull it back, move it over. Okay. Bring that over onto X. Too far. I don't know why it does that. Okay. That doesn't look too bad, I guess. Tab, B, grab these, zoom in, pull this out right about here. You know what? Easier to do, just be grab both sides and then scale on the X. Good. Say that's all connected and then that moves everything. At least it'll keep kind of everything away from getting screwed up. So all those parts are going to be the one that move up and down. So, no. So if we do travel, see, but that's the thing, like the back part, I don't even know why we would have needed to go this high if it's not gonna, because it may snap, like smack the freaking thing. Right? I feel like it would, well, this is moving, it's gonna smack the stuff. Oh no, it's out of the way. Now that I think about it, it's not building anything, it's cutting into stuff. So it may work. I don't know. Like I said, until I see it, I'm not sure, but for the most part, I'm just worried about this smacking whatever it is that I'm cutting out. But if it won't, then I'm not gonna worry about it. But I don't think I'll be able to cut anything that's this high. If you think about it, yeah, so I don't know. But so far we know for sure we need this piece, this piece, this piece, and those 4 pieces. And I say 4 because 1, 2, 3, and 4. I'm not worried about that top part just yet, until I figure out this whole gantry system stuff. But I'm gonna go ahead and end this the design here. It looks pretty good though. I actually am liking how well it came out. So I mean, this is definitely something I would want to make. And I really feel like it would be able to cut some aluminum, hopefully. I mean, it don't have to be too thick of aluminum, just some of it will be fine with me. But I hope you guys are liking the video. Please like, subscribe, let me know what you think. And my name is Legit Lee. I'm signing out.